Let's look at drilling operations on the lathe. First operation is going to be to select the proper center drill, so we'll talk a little bit about those. Then we'll follow that with installing the drill chuck into the tailstock, the center drill operation and what it's for. We'll then look at the actual drilling, followed by the post-process of countersinking the hole. So first up is to learn a little bit about center drills. Here we're going to do a center drill. Is that what you'd like to do next, Don?
If we want to put a hole in the center of your part, we would first have to center drill your part, and then we can drill it with the size drill you want or ream it, depending on what operation you need to be done.
All right. Well, let's go ahead and do a center drill. All right. We need a center drill before we just start hunking material away with this?
Yep. Now I have a center drill. Center drills are going to be noted on the side by size. That would be number 1, 2, or 3, or 4. This one is a number 3 center drill. Basically, it's going to be a 1/4-inch center drill. Okay. You have 2 tapers. You have this one that clears the tip away, and this angle is going to be the same size as your center. If I wanted to use a live center, so it supports. All right. What we're using it for is the guide to drill. Normally, if you try to drill with the drill will wander from side to side. This here will help give it a cone so the drill will follow into the hole safely.
I noticed that, like when I try to drill with my hand drill at home through sheet metal, Don, it wanders, like you said. So this center drill is going to prevent that, and it's going to guide the drill into the exact center we want it. Let's review some ideas that Don put forth about center drills. He said they come in sizes 1, 2, 3, and 4, and those sizes are stamped on the sides on the side of the center drill. We chose to use a size 3 for this movie, which is going to be a standard size for entering 153, and that has a 1/4-inch diameter shank. And what center drills do is they create a guide hole for a drill so that it doesn't wander when it's first trying to start the hole. So the center drill creates a nice cone to keep that drill centered to exactly where it needs to be. Next up, we're going to show you a small clip on how to install the drill chuck into the tailstock. Now this is very easy compared to putting in the 3-jaw chuck. Now what Don's working on here, we talked about, this was, what is this called? Is it called the tailstock?
This is your tailstock of your lathe, and what we want to do is we want to put the drill chuck in. All right, if you notice, the drill chuck has this tapered shank. All right, we want to make sure this tapered shank is clean on the outside and on the inside. So if you don't, it's basically a taper lock, just like we talked about the spindle earlier today. As it gets pulled up and drawn on that taper, it locks. The same thing is going to happen here. As I stick this in there and lock it down, it won't spin. It locks against itself. The 2 tapers, perfect match, and they lock down, and it will stop the thing from spinning. All right? So
you just push that in there and you're done?
Yep, it's all.
That's
if there was dirt or chips or burrs in there, it would not lock in.
There's nothing we tighten? There's not this or anything?
No. That's it.
How do you get it out?
All right, to get it out, I just take and crank the spindle back, and there's a knockout in the back of here, and then you can see as it pushing it. Can you see it, Brent? Can you see it? It's locked in. It don't pull out, right? So as I spin this back, it comes back, it hits. All I have to do is give it a little crank, and it pops this out.
Okay. So you just use this wheel to get it out. Right. But to get it in, you can just push it in.
Right. Yep, that's all I do.
I don't know. That just seems like magic to me.
Taper magic. Do your math, and you'll be able to figure it out.
All right. Okay. So you got the chuck.
That's more like it.
Is this the chuck?
This is the chuck.
All right. That's the chuck. That looks familiar.
Okay. Excuse me.
What about this thing? Should I get this out of the way?
No, I have enough room to work.
You got enough room. Okay. All right. So it's just like a drill. He's putting the center drill in first. He's tightening that up. This looks all familiar to me. Now, this isn't going to spin.
No.
All right.
The drill chuck and the tailstock, this doesn't spin. So in
Now,
order to get
you're using this right here, Don. What's
this is
that?
a lock. It locks my tailstock. Right
Okay.
now, my tailstock slides back and forth.
All right.
So right now I'm going to
You just lock it there for now.
turn my spindle on,
All right. Turn the, oh, now he's cranking this handle.
and that moves the spindle in or out.
Oh, okay. So look at that.
Two-thirds of the large taper.
2/3 of the large taper he's going up to.
Center drill.
All right. Isn't that cool? You're drilling, that drill's perfectly stationary. It's because the part is turning.
Correct.
So now he's turning that off. He's going to take the center drill out.
As you saw, installing the drill chuck is really child's play. All you need to do is make sure that the shaft of the chuck and the inside of the tailstock where it's going to be inserted are both very, very clean. You then just shove the chuck into the tailstock and it locks in there. Don said it's taper magic. I certainly think it is really certainly cool. To remove the chuck, you would turn the black wheel on the tailstock to retract the cylinder that protrudes from the tailstock, and there's a knockout that will knock it out. To secure the drill into the drill chuck, you use a small chuck key, and that key always has to be stored with the drill chuck when you're done using the lathe. Okay, also in this segment, we did the center drill operation. You move the tailstock near the part because there's a tailstock ways, you just push it along. Then when you're in the proper position, you lock the tailstock down with the silver lever on the side of the tailstock. You can then turn the black wheel on the tailstock to advance the drill. And Don mentioned that you want to advance the center drill so that the drill goes to a depth of 2/3 up the large taper on the center drill. So 2/3 up that large taper. All right, next we're going to look at the actual drilling.
Now the center drill created a guide for this drill to go in. Now how do we decide how deep this drill is going to go in, Don?
Well, my part, if we figure my part's going to be 1 inch and 3/4 long, I want to go long enough that I can drill through.
Okay.
So if my part's going to be 1 inch and 3/4, maybe I want to drill 2 inches.
Okay. So how do you know you're in 2 inches?
All right. First of all, I have graduation on my tailstock. I can set the 0 here. All right. And the other thing is I have a graduation on the spindle here, so I can line up. I can see where this is, so I can also look on the face. It's very hard to see, right? So I can set this thing up. There's 0. There'll be a 1/2 inch. There's millimeters as well. So I got 0, 1/2, 1 inch, etc., etc. I'll pull this out so we can see the 1 inch. There's the 1 inch.
Okay.
All right. So I can start it right about 1 inch, and I can put this at 0, and then I can bring this up to where I'm close to the work. All right. I'm not touching the part yet. I'm going to turn my spindle on. Come up. As soon as I start touching, I noticed I went about 60 thousandths past my original 0. So now I just start cutting. I can reach over and grab my...
All right, so he's going inward and then pulling it out.
breaking the chip.
Breaking the chip is also known as peck drilling.
Peck drilling, right. I want to relieve the chip. I want to get the chip out of there because if I don't, it'll just stay inside that hole. It'll bind. And if it starts to bind, I can actually drill a crooked hole. It'll bind in one of the flutes and it'll force that drill to go one way or another. And I can end up with a crooked hole. So I keep using a little bit of lubricant. And as the deeper I go, the more I want to pull it out.
That coolant looks like oil.
It is. It's a lubricant as well as coolant. See how that drill wanted to twist just there? I don't know if you've seen that. Did you see that?
Yeah.
Because I was taking too much off without clearing the chip. The chip was binding in there. 1 inch, 2 inch. I'm almost to 3 inches. 1, 2. Am I past the 2 yet? Okay.
All right, so we started at 1 inch. We wanted to go in
2 inches.
2 inches, so
I can count it off.
so we
It's 200,000, so I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 2 inches, right? It's 200. 10 times 2? Yeah, 2
Okay.
inches, right? I want a couple extra because I wasn't finding the number here.
All right. So we have drilled the hole. You have to be careful. Should we turn the machine off, Don? Or are we doing something else?
We should turn our machine off.
Okay. So while you're taking the tool out and doing anything or cleaning, you want to make sure that you turn the power off.
I'm done with my tool, so I'm going to return it back to its
All right. That's where the chuck and the key goes right in the chuck. Now, if your instructor comes by after you're done cleaning and that chuck's not in the key not in the chuck, you're gonna get him angry. Okay. What are we doing now, Don? We're gonna part this thing.
Let's take a look at what Don said about drilling. Number one, you're always going to want to do a center drill first. Otherwise, your drill could wander off the surface and not be drilled in the specified location. Next, you want to use a peck drill method to remove chips and prevent binding of the flutes. That binding could actually cause the drill to drill a crooked hole. A peck drill means you're going to go in a little ways and then retract. That will break the chips and bring them out of the hole. Every time you retract, you're also going to want to add coolant to the drill, and that's going to help lubricate and make the operation go smoother. So the peck drill is a series of advancements and retreat, advance, retreat, advance, retreat as you get further and further and deeper into the hole. Now the depth can be determined by one of two ways on the lathe. Number one, you can count the number of turns that you make on the tailstock wheel and then multiply that by 200 thousandths per turn, or 0.2 inches. So in this case we did 10 turns, so 10 times 0.2 gave us 2 inches. The other thing is you could use the scale that's etched into the side of the cylinder on the tailstock, and in our case we started with 1 inch being protruded out, and then when we were finished 3 inches were out, so you could do the difference between the two, 3 minus 1, which gave us the 2 inches. Next operation, this is our post operation of the drilling, is to perform a countersink. So let's watch what Don does on that one.
A couple more operations. We're going to countersink the hole. Don, what is a countersink and why do we want to do it?
All right. Countersink is basically a deburr tool. Two things we can use a countersink for. One is for a flathead screw or just plainly deburring a hole. So
that cutter is a countersink.
Yep.
All right, is there a degrees on it?
yes, if you're going to use it as a countersink for an American thread, you need to make sure that the angle is at 82 degrees. And if it's going to be a metric, you need to make sure you have a 90-degree countersink. If you're just deburring a hole, it can be either or.
And is that what we're doing, just deburring?
Yes.
So it doesn't matter. You could use the 82 or 90.
Right.
Okay. All right. So how far are you going to shove this in there, Don?
10% of the hole size, so about 25 thou.
All right, 10% of the diameter of the hole. With Don's experience, he kind of just knows what's right. You would probably have to measure. All right, so that's a hole drilled, center drilled, and then countersunk. All right. All right. You happy with that?
The countersink was the post process for drilling, and it has two uses. It could be used either for flathead screws so that they seat down and the top of the screw is flat with the top surface of the hole. Or in the case for us, we just use it for deburring or taking off the sharp edges off the top of the hole. Now, when doing deburring, it's not important exactly what the degrees are on the countersink. 82 or 90 is fine. If you're using for flathead screws, the 82 degrees is for SAE screws or American, 90 degrees for metric. The idea on a deburring operation is to just put a nice chamfer on the top of the hole. Don recommended about a 10% increase in the hole diameter. So if you're starting with a hole of, let's say, 0.25 inches, which would be a quarter inch, you'd want to expand that up to 0.275. All right. Now that's usually not important that that be perfectly exact. Don showed what a nice counter sink looked like in this movie. Your lab instructor can give you more guidelines if something more exact is needed. Let's review with some questions now that you can answer and hand in to your lab instructor. Number one, how is the drill chuck installed and removed from this tailstock? Number two, what is the purpose of using a center drill prior to drilling? 3. Where must the drill chuck key be stored when you are done using the lathe? Number 4. What must be done to prevent a drill from drilling a crooked hole? And 5. Why was a countersink operation performed in this movie? How large should the countersink expand the diameter of the drilled hole? Next movie will show you how to get your part out of the collet there by using a parting tool, and it'll be our last lathe operation.